Chapter 12 Mass Storage System. Presenter Mark M.R. My Between. Chapter 12 Mass Storage Systems have three topics: overview of mass storage structure, disk structure, disk scheduling. Overview of mass storage structure. Magnetic disks provide bulk of secondary storage of modern computers. Drive rotate 60 to 200 times per second. Transfer rate at which data flow between drive and computer. Positioning time to move disk arm to desired cylinder. Desired sector to rotate under the disk head. Disk can be removable. Drive attached to computer via input and output buses. Included enhanced integrated drive electronics, ATA or advanced technology attachment, SATA or serial advanced technology attachment, USB or universal serial bus, fabric channel, or SCSI or small computer system interface. Host controller in computers uses bus-to-talk to disk controller built into drive or storage array. Moving head disk mechanism. In modern computers, most of the secondary storage in the form of magnetic disk. Hence, knowing the structure of magnetic disk is necessary to understand how the data in the disk is accessed by the computer. Magnetic disk contains several platters. Each platter is divided into circular shaped tracks. The length of the track near the center is less than length the tracks farther from the center. Each track is further divided into sectors, as shown in the figure. Tracks of the same distance from the center from a cylinder. A read-write head is used to read data from a sector of the magnetic disk. The speed of the disk is measured as two parts. Transfer rate. This is the rate at which the data moves from the disk to the computer. And the random access time. It is the sum of the seek time and rotational latency. Disk structure. Disk drives are addressed as large one-dimensional array of the logical blocks, where the logical block is the smallest unit of transfer. One-dimensional array of logical block is mapped into the sector of the disk sequentially. Sector 0 is the first sector of the first track on the outermost cylinder. Mapping processed in the order through the track, then the rest of the tracks in the cylinder, and then through the rest of the cylinders from the outermost to innermost. This is scheduling. The operating system is responsible for using hardware efficiently. For the disk drives, this means having a fast access time and the disk bandwidth. Access time has two major components. Seek time is the time for the disk arm to move the head to cylinder containing the desired sector. Rotational latency is the additional time waiting for the disk to rotate the desired sector to the disk head. Minimize seek time. Seek time distance disk bandwidth is the total number of the bytes transfer divided by the total time between the first request for the servers and completion at the last transfer. This is scheduling. Several algorithms exist to schedule the servicing of the disk input-output request. illustrate them with the request of Q from 0 to 199, 88, 183, 37, 122, 14, 124, 65, 67, and had a head pointer 53. And C and FCFS, or first come first serve illustration, show total head movement of 640 cylinders with a Q of 98, 183, 37, 122, 14, 124, 65, and 67. Have an head starts at 53. Assume the head is initially at the 53. The head moves in the given order of in the queue. SSTF, or shorter seek time first. Select the request with the minimum seek time from the current head position, or SSTF scheduling is from the form of SGF, or shortest job first schedule, may cause starvation of some requests. Here is the show the total movement of 236 cylinders with a Q of 98 starts. Head starts at 53. The position with the closest to the continued head position is chosen first. Consider the previous example where the desk queue looks like. The next closest cylinder to 53 is 65, and then the next nearest one is 67, and then (37), 14, and so on. Scan. The disk arm starts at one end at the disk and moves towards to other end, servicing request until it gets to the other end of the disk where the head movement is reversed and servicing continues. Scan algorithm, sometimes called elevator algorithm. Illustration shown the total head movement of 236 cylinders. Here the illustration shows, which is the head starts at 53, followed by 37, and 14, 0, and so on. C-scan provides a more uniform wait time than S-scan. The head moves from one end of the desk to the other, servicing request at it goes. When it reaches the other end, however, it immediately returns to the beginning of the desk without servicing any request on the return trip. Treats the cylinders as the circular list that wraps around from the last cylinder to the first one. Here is the illustration below shown. Head start at 53, followed by 65, 67, 98, 122, 124, and so on. C-loop version of C-scan. Arm only goes as far as the last request in each direction, then reverses direction immediately without first going all the way to the end of the disk. Here is the illustration below shown. which had head start at 53, 65, 67, then 98, 122, and so on. Selecting a disk schedule algorithm, SSTF is a common, has a natural appeal. C-scan and scan perform better for systems that place a heavy load on the disk. Performance depends on the number of types of requests. Requests for the disk service can be influenced by the file allocation method. The disk scheduling algorithm should be written as a separate module of the operating system, allowing it to be replaced with a different algorithm if necessary. Either SSTF or Loop is a reasonable choice for the default algorithm. Thank you.